March 24, 1941, Quonset Point Naval Air Station, Rhode Island. The George A. Fuller Company's engineering team studied the stack of blueprints spread across the conference table. Calculations that would have to become reality in less than 60 days. The United States Navy had just issued an impossible challenge: design a portable building that untrained men could assemble in enemy territory using only hand tools. Make it stronger than anything the British had used in the First World War, and do it all before summer. Across the Atlantic, the British Nissen Hut had served its purpose for 25 years. 6 men with 4 hours of work could erect one on a prepared concrete base. The record stood at 1 hour 27 minutes, achieved by a well-rehearsed Royal Engineers team under perfect conditions. But the American military needed something faster, something better, something that would change the mathematics of warfare itself. What neither the British nor the Germans understood in 1941 was that American industrial philosophy was about to rewrite the rules of prefabricated construction. The difference between the Nissen Hut and the coming Quonset Hut would not be measured in inches or pounds. It would be measured in the revolutionary idea that speed of assembly mattered more than tradition, that simplification trumped complexity, and that any soldier with a hammer should be able to build shelter as easily as he could fire a rifle. The story of how America built a structure in one day while Britain needed a week reveals more than engineering prowess. It exposes the fundamental difference between two industrial philosophies, 2 approaches to war, and 2 visions of what prefabricated construction could achieve. This is the story of the Quonset Hut, the structure that could be assembled faster than any military building in history, and the innovation that made it possible. The British Nissen Hut was born from necessity. In April 1916, Major Peter Norman Nissen of the 29th Company Royal Engineers began experimenting with semicircular shelter designs. As the Battle of the Somme approached, the Western Front demanded housing for hundreds of thousands of newly conscripted troops, and traditional construction methods could never keep pace. Nissen, a Canadian born mining engineer and inventor, drew inspiration from an unlikely source. The drill shed roof at Queen's University in Kingston, Ontario, had featured a semi-cylindrical design that collapsed in 1896. Nissen adapted this curved shape, recognizing that a semicircular structure would deflect shrapnel and bomb blasts better than rectangular buildings with vulnerable right-angle corners. Between April 16 and April 18, 1916, Nissen constructed 3 prototype huts. His design underwent intensive review by fellow officers including Lieutenant Colonel Shelley Sue and MacDonald and General Clive Gerard Little. After the 3rd prototype proved successful, the design was formalized in August 1916. The Nissen Hut was elegantly simple in concept. Curved corrugated steel sheets formed the exterior skin attached to T-shaped steel ribs set at 6 ft intervals. These ribs were bolted to floor bearers at each end. Wooden pollens ran lengthwise between the ribs, providing attachment points for the corrugated panels. The structure came in 3 standard widths. 16 ft, 24 ft, and 30 ft. Length came in multiples of 6 ft, with the most common configuration being 16 ft wide by 36 ft long. The exterior used corrugated steel sheets measuring 10 ft6 and x2t2 in. These overlapped by 6 in at the ends and by 2 corrugations at the sides. About 54 sheets covered a typical 16 ft hut. Inside the structure could be lined with additional corrugated panels or pressed wood, creating an air and space for insulation. The ends were capped with wooden frames containing doors and windows. Construction required a prepared concrete base, 6 men, and about 4 hours of work under normal conditions. The crew bolted the steel ribs to the foundation, attached the wooden pollens to the ribs using hook bolts, then nailed the corrugated sheets to the pollen. Straining wires on each side of each rib had to be tensioned during assembly to prevent the structure from spreading. The hut could be packed into a standard 3-ton army wagon for transport. By the end of World War I, at least 100,000 Nissen Huts had been manufactured. Major Nissen received promotion to lieutenant colonel, was awarded the Distinguished Service Order, and patented his invention in the United Kingdom, United States, Canada, South Africa, and Australia. Remarkably, he waived all royalty rights for the duration of the war, and Nissen Buildings Limited would do so again during World War II. The Nissen Hut was not beloved by those who lived in it. Soldiers in the United Kingdom found them cold and drafty. Those serving in the Middle East, Asia, and the Pacific found them stuffy and humid. The airspace insulation provided minimal thermal protection, Early models had dirt floors, no electricity, and only potbelly stoves for heating. But they were portable, reusable, and far better than tents in combat zones. Production waned between the wars but revived in 1939. Similar designs emerged, including the Romney Hut in Britain and eventually the Quonset Hut in America. The Nissen remained the standard until a new generation of American engineers asked a revolutionary question. What if we eliminated the internal framework entirely? March 1941, the George A. Fuller Company of New York received an urgent request from Admiral Ben Morrell, chief of the Bureau of Yards and Docks. The Navy needed thousands of prefabricated structures for bases being constructed along the Atlantic seaboard and throughout the Pacific. These buildings had to be lightweight enough to ship anywhere, strong enough to withstand hurricanes and typhoons, and simple enough that untrained personnel could erect them using only hand tools. The Fuller Company had already been awarded the contract to construct facilities at Quonset Point Naval Air Station in Rhode Island. The firm was one of America's largest construction contractors, having built the Flatiron Building in New York and the Lincoln Memorial in Washington. Now, the company's design team, led by architect Otto Brandenberger with engineers Robert McDonald, Tomasino Secondino, and Dominic Ergo, received what seemed like an impossible assignment: design a revolutionary prefabricated shelter, build a factory to manufacture it, deliver the first units, all within 60 days. The Navy provided the Fuller team with plans for the British Nissen Hut as a starting point. Brandenberger and his colleagues studied the design and recognized both its strengths and limitations. The semicircular shape was structurally sound and aerodynamic. The corrugated steel was weatherproof and relatively lightweight. But the Nissen Hut's reliance on an internal framework of steel ribs with bolted connections created complexity that slowed assembly. The Fuller team made a crucial decision. They would keep the semicircular shape, but completely reimagine the structural system. Their innovation would eliminate much of the field assembly time by moving complexity from the construction site to the factory. The Fuller Company threw up a sprawling manufacturing plant near Davisville, Rhode Island in 30 days. So confident were they in their design approach that production began even as the engineering team continued refining details. This aggressive timeline would prove typical of American wartime industrial philosophy. Perfect later, produce now. The original Quonset design, known as the T-rib model, measured 16 feet wide by 36 feet long, with an 8T radius. Like the Nissen Hut, it used T-shaped steel ribs as the primary structural frame. But the American version made critical improvements. The ribs were formed from two deformed sections of steel channel tack welded back to back. This created a serpentine nailing groove running the length of each rib. The groove was shaped like a stretched-out letter W when viewed end-on. This seemingly minor detail would prove revolutionary. Instead of drilling holes and inserting bolts to attach the corrugated outer skin and inner lining, workers could simply drive nails through the materials into the grooved ribs. The W-shaped bends gripped nails more tightly than wood. The exterior used corrugated galvanized steel panels bent by the Anderson Sheet Metal Company of Providence, Rhode Island, which developed specialized equipment to curve the sheets to the required radius. The interior featured masonite-pressed wood lining. Between the outer steel and inner lining, paper insulation provided far better thermal protection than the airspace in Nissen Huts. The floor used one-in-tongue and groove plywood supported on a raised metal framework. The ends were capped with pre-assembled plywood sections containing doors and windows. The Quonset could be placed on concrete foundations, on pilings, or directly on the ground. The entire structure cost approximately $800 to manufacture, equivalent to about $12,000 today. But the true innovation was in the assembly system. The Fuller Company delivered Quonset Huts in shipping crates. Early versions required 12 crates totaling 3,212 empty. Within months, improved packing methods reduced this to just 3 crates. A 10-man crew using only hand tools, mainly hammers, could erect a complete T-rib Quonset in one day. No special skills required. No heavy equipment needed, just ordinary soldiers with hammers driving nails into grooved steel ribs. In June 1941, the Navy shipped its first Quonset Huts overseas under Lend-Lease to Britain. The British, who had invented the Nissen Hut 25 years earlier, now received structures that could be assembled faster and provided better living conditions. By the end of 1941, approximately 8,200 T-rib Quonset Huts had been produced. Early field reports from Iceland proved the design's superiority. A hurricane-force gale ripped the covering completely off many British Nissen Huts and crumpled PBY flying boats on the beach like paper. The Quonset Huts emerged practically undamaged. December 7, 1941 changed everything. The Japanese attack on Pearl Harbor brought America fully into World War II. The Army immediately ordered 16,000 Quonset Huts. Demand would only accelerate as the war expanded across 2 oceans and 6 continents, but even as production ramped up, engineers identified problems with the T-rib design. The curved walls extended all the way to the floor, creating unusable space along the sides. Beds, sinks, washing machines, and equipment had to be moved inward, wasting valuable floor area. Additionally, some commanders wanted even faster assembly and lighter shipping weight. The Fuller Company developed the Quonset redesign model with 4 FT vertical sidewalls, supporting a modified arch. This reclaimed floor space and made the interior more functional. The new arch assembled in 2 sections instead of 3, reducing erection time and the number of fasteners required. The modified design used an I-shaped steel member produced by Strand Steel, a subsidiary of Great Lakes Steel Corporation. Approximately 25,000 redesign huts were manufactured at West Davisville, but Strand Steel, already established in the lightweight steel framing market, saw an opportunity to improve the Quonset even further. The company had showcased its residential steel framing system at the 1933 Chicago World's Fair in the Homes of Tomorrow exhibit. Now Strand Steel engineers proposed taking over production and implementing their own revolutionary manufacturing system. In late September 1941, the Navy awarded Strand Steel a contract for Quonset production. Design approval came in October. Over the next year, Strand Steel gradually assumed primary production responsibility. By 1943, when the factory at Quonset Point was phased out, Strand Steel had become the dominant manufacturer. Otto Brandenburger remained project leader throughout the transition, but the design underwent a complete transformation. The Strand Steel Quonset reverted to the full arch shape, sacrificing some floor space in exchange for dramatically improved manufacturing efficiency and portability. The key innovation was in the steel ribs themselves. Strand Steel abandoned the T-rib entirely. Instead, they created ribs from 2 lightweight steel channels welded back to form an I-shaped member. Between the channels ran a serpentine groove, even more efficient than the original T-rib design. This groove allowed workers to use friction-held nails instead of bolts throughout assembly. The new ribs were 35% lighter than T-ribs and 60% less expensive to produce. More importantly, they could be fabricated in 2 sections instead of 3 with simpler splice plate connections. This reduced the number of pieces that had to be tracked, shipped, and assembled in the field. The Strand Steel Quonset measured 20 FT wide by 48 FT long. Despite being larger than the original 1636 FT T-rib model, it weighed less and occupied less shipping space. The floor system changed from 1-in floorboards to half-in plywood. Lighter gauge galvanized siding replaced the heavier steel used earlier. The siding layout was modified so that only factory curved panels were used along the ridgeline. The remainder of the hut used horizontally installed panels that could ship flat, further reducing transportation volume. When created, a complete Strand Steel Quonset required just 270 to 325 cubic feet of space, compared to 450 cubic feet for the redesign model. This was less space than canvas tents with wooden frames required. The assembly instructions were masterpieces of simplicity. Lay out the floor framework and install plywood flooring. Position and bolt the steel rib sections together. Stand the ribs upright and bolt them to the floor framework at 6 FT intervals. Install the nailing strips between ribs. Nail the corrugated steel panels to the ribs and strips starting at the ridge and working down each side. Install the interior masonite lining by nailing it to the ribs. Attach the pre-assembled end walls. Install doors, windows, and any interior partitions. Connect ventilation and heating systems if required. 10 men with hammers, wrenches, and basic hand tools could complete the entire process in 1 day. 8 hours. No cranes, no welding equipment, no specialized skills, just soldiers following printed instructions and driving nails into grooved steel. The Strand Steel manufacturing system transformed Quonset production from craft to industrial process. The Great Lakes Steel Corporation factory in Detroit operated multiple production lines simultaneously. Steel coils arrived by rail and were formed into channels by progressive stamping dies. The channels were cut to length, paired, and tack welded to create the grooved ribs. Rib sections received splice plates and bolt holes in precise locations. Corrugated panels were sheared to size. with some bent to the required radius for ridge installation. Plywood was cut for flooring and end walls. Doors and windows were prefabricated. Every component was designed for interchangeability and foolproof assembly. Compare this to British Nissen Hut production. The Nissen required skilled workers to bolt dozens of connections between ribs and purlins. Each corrugated panel had to be positioned precisely and secured with hook bolts. The straining wires had to be carefully tensioned to prevent structural spreading. Weather conditions affected bolt installation. Rain made steel slippery. Cold made fingers clumsy. The assembly process was sensitive to crew experience and environmental conditions. The Quonset, by contrast, was remarkably forgiving. Nails could be driven in any weather. The grooved ribs automatically aligned panels. The eye-shaped steel members were inherently more rigid than T-sections, reducing the need for supplementary bracing. An inexperienced crew might take 12 hours instead of 8, but they would still complete the hut successfully. The difference was philosophical. British engineering emphasized getting the design right and then training crews to execute it properly. American engineering emphasized making the design so simple that untrained crews couldn't get it wrong. The British optimized for skilled labor. The Americans optimized for unskilled labor at scale. By 1943, the advantages of American methods were measurable. A Nissen Hut required 6 men and 4 hours under ideal conditions with an experienced crew. A Quonset Hut required 10 men and 8 hours with no experience necessary. This sounds like the Quonset took longer, but factor in reality. A typical Nissen Hut crew after training could maintain the 4-hour standard about 60% of the time. Bad weather, crew fatigue, or difficult terrain easily doubled assembly time to 8 hours or more. A Quonset crew working in identical conditions might take 10 hours on their first attempt, 9 hours on their second, and reliably 8 hours thereafter. The Quonset's ease of assembly meant less variance, more predictability, and ultimately faster deployment at scale. More importantly, the Quonset required less skilled oversight. A sergeant with basic literacy could supervise Quonset assembly using printed instructions. Nissen construction required at least one experienced crew member who understood structural principles and proper tensioning procedures. In a rapidly expanding military with millions of newly inducted personnel, this difference mattered enormously. The statistics tell the story. During World War II, Britain produced approximately 100,000 additional Nissen Huts beyond those built in World War I. The United States manufactured between 150,000 and 170,000 Quonset Huts between 1941 and 1945, with the higher figure representing all variations including warehouse models. American production exceeded British output despite starting 25 years later, and did so while simultaneously building Liberty ships, tanks, aircraft, and every other implement of war. The Quonset Huts went everywhere American forces went. They served as barracks in Iceland and the Aleutian Islands, weathering temperatures far below zero. They functioned as hospitals in North Africa and Italy. They provided offices and warehouses in England in preparation for D-Day. They housed personnel on Pacific islands from Hawaii to Okinawa. The Navy approved Quonset Huts for 86 official uses, including barracks, chapels, isolation wards, latrines, bakeries, medical offices, dental offices, mess halls, warehouses, and repair shops. The largest Quonset Hut ever built was a 54,000 FT warehouse on Guam. Technically designated as a multiple building, this massive structure used rectilinear steel frames with arched roof segments that could expand in both directions, representing an evolution of standard Quonset design. The standard 4100 FT model earned the nickname Elephant Hut. These massive structures provided clear span space for aircraft maintenance and supply storage. Smaller 28-48 FT huts called the Quonset 20 became the most common variant. The Pacific War showcased Quonset advantages most dramatically. Island hopping strategy meant establishing bases on coral atolls with no infrastructure. Everything had to arrive by ship. Construction crews faced tropical heat, torrential rain, typhoons, and often Japanese artillery. Speed mattered. Simplicity mattered. Durability mattered. Navy construction battalions, the famous CBs, became experts at rapid Quonset deployment. A well-organized CB unit could offload Quonset crates, transport them inland, prepare foundations, and complete multiple huts in a single day. The structures that rose from jungle and coral became symbols of American industrial power, projected across 10,000 miles of ocean. The Seabees developed specialized techniques for Pacific construction. On islands with suitable coral bedrock, they poured concrete slabs directly on leveled coral. Where soil conditions were poor, they drove wooden pilings or used steel frameworks to elevate structures above potential flooding. In areas subject to typhoons, they anchored huts with additional steel cables driven deep into coral or bedrock. The speed of Seabee construction operations astounded observers. At Tinian Island in the Marianas, construction battalions erected an entire air base complex, including dozens of Quonset Huts in a matter of weeks. The base would support B-29 Superfortress operations against Japan, including the aircraft that dropped atomic bombs on Hiroshima and Nagasaki. Every maintenance hangar, every supply depot, every operations building that supported those missions began as crated Quonset components offloaded from cargo ships. At Guadalcanal, Seabees constructed Quonset complexes while Japanese forces still occupied parts of the island. Construction crews worked under sporadic artillery fire and nightly air raids. The ability to erect functional buildings quickly, even under combat conditions, provided American forces with logistical advantages that Japanese commanders could not match. While Japanese troops sheltered in jungle dugouts or makeshift structures, American personnel operated from organized facilities with electric lighting, proper sanitation, and weather protection. British forces continued using Nissen Huts throughout the war, particularly in North Africa and the European theater. The Nissen remained a perfectly adequate structure. 6 men and 4 hours was respectable, but adequate was no longer enough in an era when entire air bases had to be constructed in weeks, and fully equipped divisions needed housing within days of landing. The contrast between British and American approaches appeared most starkly in North Africa. British forces in Egypt and Libya relied on Nissen Huts supplemented by tents. Construction required skilled Royal Engineers detachments. American forces arriving in late 1942 brought Quonset Huts that ordinary infantry could erect. British commanders observed with interest as American bases materialized with remarkable speed. The German military watched Allied construction capabilities with growing dismay. German war production focused on weapons and vehicles. Prefabricated housing received low priority. German troops often lived in captured buildings, tents, or hasty dugouts. The sight of American bases with hundreds of identical metal huts, electric lighting, hot water, and organized layouts reinforced the impression of limitless industrial capacity. German intelligence reports from 1943 onward documented American base construction with increasing alarm. Luftwaffe reconnaissance photographs showed Quonset complexes appearing on Pacific Islands, in North Africa, and in England. German analysts calculated construction rates and extrapolated American production capacity. The numbers defied belief. How could any nation manufacture tens of thousands of prefabricated buildings while also producing aircraft, ships, and tanks in unprecedented quantities? The answer lay in American industrial organization. Strand Steel operated as one component of Great Lakes Steel Corporation, itself one division of a vast industrial network. The same manufacturing principles that produced Quonset Huts applied to Liberty ships, aircraft components, and tank hulls. Standardization, prefabrication, assembly line methods, interchangeable parts. These concepts permeated American war production. The Quonset Hut exemplified the system but was not unique within it. After the war ended in 1945, the Quonset Hut faced an uncertain future. Would these utilitarian military structures have any peacetime purpose? The answer came quickly. A desperate housing shortage affected the entire nation. Government estimates indicated a need for 3.5 million additional homes in 1946 alone. Returning servicemen and pent-up wartime demand created a housing crisis. The War Assets Administration organized sales of surplus Quonset Huts at Port Hueneme, California. 11 Quonset Huts were offered to World War II veterans. On the first day, 75% were claimed by 600 veterans. Similar sales occurred nationwide. Prices ranged from $295 to $1,000 per hut, depending on size and condition. Veterans could purchase a complete structure for less than the cost of materials for conventional construction. However, buyers faced the problem of transportation. Each hut weighed approximately 6 tons when disassembled. Rail shipping cost 32 cents per 100 pounds, though 6 veterans could pool resources for a discounted rate of 10.5 cents per 100. Many veterans hired trucks to transport huts to their land, creating an unusual sight on American highways. Once delivered, assembly remained straightforward. The same simplicity that allowed soldiers to erect huts in combat zones worked equally well for civilian veterans. A veteran with several friends could erect a Quonset in a weekend. The resulting structure provided more space than many apartments and cost far less than conventional housing. Universities acquired hundreds of Quonset huts for married student housing. The University of Iowa created Quonset Park, an entire community of curved steel structures. Yale University housed married students in Quonsets until well into the 1960s. Roger Young Village in Los Angeles became an entire community of Quonset Hut homes for veterans and their families. Named after a Medal of Honor recipient killed in the Solomon Islands, the village occupied land near Griffith Park. At its peak, Roger Young Village housed approximately 1,500 families in 750 Quonset huts. Life in Roger Young Village resembled small-town America, transplanted into curved steel. Residents formed community organizations, organized sports leagues, held dances and social events. Children attended schools on site. Yet residents understood the temporary nature of their housing. As veterans found jobs and saved money, they moved to conventional homes. By the mid-1950s, Roger Young Village had largely emptied. The site was cleared and redeveloped. Farmers purchased Quonsets for hay barns, equipment storage, and livestock shelter. Small businesses used them for workshops, warehouses, and retail spaces. Brothers Owen and Harold Bradley installed a surplus Quonset as a recording studio in Nashville in 1954. The studio, located at 804 16th Avenue South, became known simply as the Quonset Hut. Its curved steel structure created excellent acoustics that helped pioneer the Nashville sound. Patsy Cline recorded Walkin' After Midnight there in 1957, followed by I Fall to Pieces and Crazy. Conway Twitty recorded his first hit, It's Only Make Believe, in 1958. Loretta Lynn recorded 5 albums at the studio, including her first studio album in 1963. Johnny Cash recorded his second studio album there in 1958, plus Ring of Fire in 1963 and Jackson with June Carter in 1967. Owen Bradley later became a producer and vice president for Decca Records, Nashville division starting in 1958. Columbia Records purchased the studio in 1962, and it continued operating as Columbia Studio B. But the Quonset quickly fell from favor as family housing. Veterans found that the curved walls reminded them too much of military service. The standard Quonset 20 provided only 960 square feet of floor space, with much of it unusable due to sloping sides. This was too small for growing families in post-war America. By the early 1950s, most Quonset hut communities were being replaced by conventional housing developments. Yet the Quonset endured in other roles. Thousands remained in service at military bases. Many found second lives as farm buildings, where the clear-span interior and weather-resistant steel construction proved ideal for equipment and crop storage. Today, 70 years after World War II ended, Quonset huts still dot the American landscape, testament to over-engineered wartime construction standards. The Nissen Hut story followed a different trajectory. After World War II, many British Nissen Huts were converted to agricultural or industrial use. Thousands housed post-war migrants in Britain, Australia, New Zealand, and other Commonwealth nations. 50 Nissen Huts built as private housing in Belmont, North New South Wales, Australia became a unique residential community. 17 have been demolished over the decades, but the remaining 33 have been refurbished and remain occupied today. In Britain, scattered Nissen Huts survive at former military installations now serving as workshops, storage buildings, or historical exhibits. The Chiltern Open Air Museum displays a World War II-era Nissen Hut with an authentic Royal Air Force briefing room interior. Some have been converted to businesses, demonstrating the enduring utility of wartime designs. The contrast between Quonset and Nissen Hut design philosophies reveals broader differences in American and British engineering culture. British design emphasized elegance and efficiency within the manufacturing process. The Nissen Hut used relatively few components. Its T-shaped ribs and corrugated panels were straightforward to produce. The design assumed that trained crews would handle assembly. American design emphasized simplicity at the point of use. Strand steel added complexity to the manufacturing process, creating grooved ribs that were more difficult to produce than simple T-sections. But this manufacturing complexity enabled field simplicity. The grooved ribs transformed assembly from a task requiring skill into a task requiring only effort. This philosophy extended throughout American wartime production. The M1 Garand rifle was more complex to manufacture than the British Lee Enfield, but easier for conscripts to maintain. American tanks used simple transmissions that any mechanic could repair, while German tanks had sophisticated but maintenance-intensive powertrains. American cargo ships, the Liberty ships, were built using standardized components and assembly line methods that enabled 3 ships per day production at peak. Speed of deployment mattered more than elegance of design. Ability to train unskilled workers mattered more than perfection of execution. Volume of production mattered more than individual unit quality. These principles, controversial at the time, proved decisive. The numbers demonstrate American mass production philosophy. Between 150,000 and 170,000 Quonset Huts in 4 years of war production. Taking the midpoint of 160,000, that's approximately 308 huts per week, 44 per day, nearly 2 per hour every hour around the clock for 4 years. No individual craftsman could match such output. No traditional construction method could approach such scale. Modern prefabricated construction owes enormous debt to the Quonset Hut. The principle of moving complexity from field to factory underlies everything from modular homes to contemporary steel arch buildings. The grooved rib innovation finds echoes in modern construction. Steel studs for residential framing use channels that grip drywall screws through friction. Prefabricated wall panels use proprietary connection systems that eliminate traditional framing skills. The principle remains constant. Make the component smart so the worker doesn't have to be. Today, companies worldwide manufacture Quonset-style buildings using 21st century materials and methods. Modern versions use galvanized steel with advanced anti-corrosion coatings. Engineered designs can withstand Category 4 hurricane winds and extreme snow loads. The basic concept remains unchanged. A semicircular cross-section provides inherent strength. Prefabricated components ship efficiently. Field assembly requires only basic tools. In Alaska, where thousands of World War II-era Quonset Huts remain, the design has become so ubiquitous that some areas restrict new construction to avoid proliferation. The old military huts built with wartime urgency 70 years ago continue functioning as homes, businesses, and storage buildings, testament to over-engineered wartime construction standards. The story of the Quonset Hut is ultimately about industrial philosophy. Britain created a good design and assumed trained users would execute it properly. America created a design so simple that untrained users couldn't execute it improperly. Both approaches had a merit. But in total war requiring rapid mobilization of millions of civilians into military service, the American approach proved superior. The difference between assembling a building in 4 hours versus 8 hours seems modest, but multiply across thousands of bases on 6 continents over 4 years of war. The Quonset Hut's ease of assembly represented thousands of man-hours saved, thousands of soldiers freed for other duties, thousands of structures erected by crews who would have struggled with more complex designs. Speed of construction alone did not win World War II, but the ability to project industrial capability anywhere on Earth, to establish functioning bases on remote islands within weeks, to house and supply millions of personnel in dozens of countries simultaneously. These capabilities shaped the war's outcome. The Quonset Hut was one small piece of a vast industrial machine, but it exemplified the principles that made that machine unstoppable. A 10-man crew with hammers could build a Quonset Hut in 1 day. That simple fact represented a revolution in military construction, a testament to American manufacturing philosophy, and a contribution to Allied victory that historians often overlook. The British Nissen Hut served honorably for 30 years. 6 men in 4 hours was an impressive achievement for 1916 technology, but by 1941 the world had changed. Total war demanded industrial-scale solutions. The Quonset Hut delivered those solutions through a deceptively simple innovation. Make the structure so easy to assemble that anyone could do it. Today, when we see a curved metal building housing farm equipment or serving as a small business workshop, we're looking at the descendants of that World War II innovation. The Quonset Hut proved that revolutionary advances don't always require exotic materials or complex technologies. Sometimes revolution comes from asking a different question. Not how can we build this better, but how can we make it so simple that anyone can build it at all? In the end, that was America's secret weapon in World War II. Not just the ability to produce more tanks and planes and ships than anyone else, but the philosophy that every product, every system, Every structure should be designed for mass production by ordinary workers and field deployment by ordinary soldiers. The Quonset Hut, assembled in one day by 10 men with hammers, embodied that philosophy perfectly. It was not the most elegant solution, but it was the most effective solution at the scale that mattered. The British Nissen Hut was good. The American Quonset Hut was good enough, faster and simpler. In 1941.